Taking a look at problem 1-34, we're looking at this graph and figuring out in problem A the possible x values on the graph, which is the domain for that graph. The x values are going to go from here at -2 over to here at +4. So the domain of this graph is going to be -2 to +4. The x values are between that, so the x values are going to be greater than or equal to -2. And I know it's going to be or equal to because that is a closed circle there. And the x values are going to be less than or equal to +4. So they're everywhere in between here, greater than -2 but less than 4. Problem B, we are taking a look now at the possible outputs, which is the range. So the range goes down from -1 up to +3. So it is all the values in between there. So the range is going to be -1 is less than or equal to, again I know it's or equal to because of the closed circles, it actually touches that point. Y is free range, which is less than or equal to +3. Problem C now is talking about range again, but this time the person thinks it is just these integer values. Just -1, 0, 1, 2, and 3. And there are values there. However, there are also values in between. So since we have a continuous function, it is a smooth curve all the way through those points, we not only have the points they are talking about, but we also have the decimals that are between them. So Ricky is not correct because we have all the decimal points that are between those integers as well. And the last problem, if I'm looking at the same domain and same range, all I need to do is draw another function that would fit essentially inside of this box. So I can draw anything that's going to start on one end and end on the other, as long as it touches the top and the bottom of the box. And that would be another function.